go. So here's our general plan for the day. We'll get started with welcome and introductions, going over the plan. We'll talk a little bit about the set of tools that are available to you to try to work with big or really big data in R. And this is a set of tools that's much larger than we're going to talk about today, but it can be good to have a little bit of an awareness of how everything fits together. And then we'll get into doing data storage and access using Arrow, which we are going to be using the Arrow R package, which is put out as a way to use some of these Apache Arrow functionality with R. And then we'll show doing some data wrangling, as you might be familiar with the dplyr package, using Arrow. And then after a break, we're going to look at ways to make Arrow even more useful by combining it with this database engine that also has an R package implementation called DuckDB. And then we'll talk about using DuckDB on its own and extending the capability of DuckDB by writing raw SQL code and passing it through DuckDB. And we'll finish up with a little bit of a higher level conversation about when to use which sorts of tools and what they might be better suited to, and wrap up. Yeah, so I'm glad you're all here. A little bit of context about these workshops and who we are offering these workshops. I and others of us on the call, including Eric and Christina, are part of the CCT Communications and Cyber Technologies Data Science team. And our mission is to support reproducible research, data pipelines, and software development in ALVSCE. And we also work with folks across the whole university. And we do that a whole bunch of ways, including workshops. We also hold drop-in hours every Tuesday morning virtually on GatherTown. We have an incubator program where if you're part of ALVSCE, you can work with us for 80 hours of our time on a sort of focused and scoped data science project, or we're available to scope out and participate in longer term collaborations. So we're available for all these kinds of work. We're really happy to see you here at workshops. And if you want to learn any more about us and what we do, our website is at this link. Before we get started, trying to do any more, couple of logistics. Sorry, my screen's messed up. So these slides and all of the links in these slides are going to be available at the URL in the slide, which I'll also drop in the chat so you can all find it. I sent around an email before the workshop, and if you haven't had a chance to just make sure that you have R and RStudio installed on your computer, we're going to be doing some code along today using RStudio. And we're going to be using these packages, which I sent out most of these in the email, and then I realized that I've also got some code that uses the TikTok package, which you don't need. It's fine if you don't have it. It's just for seeing how long things take. But either way, if you haven't yet tried to install these packages, please do. I'll drop the list of them in the chat. Some of these can take a little while, so it would be best if you can get started running those installations while we do some of this introductory material in the workshop. And we can troubleshoot if you run into any installation problems, especially with Arrow, as we've seen. Lastly, we are going to be working with some, and I just followed that link. We're going to be working with some toy data today. This is not a huge download. It's actually a very small data frame. And it's structured as an R project. And so if you follow this link, you'll be taken to this box page, and you should be able to, at the top right of the page, click on this little download button, and that should give you the option to download this whole folder as a .zip file, and unzip it, and you'll be good to go for running any of the code in today's slides. That's kind of a lot. Should I pause for a second to give folks a chance to start running this code? Jessica's asking if the R script is meant to be empty. Yes, it's just a placeholder so that we have a place to put some code. Great question, though. So it's fine if that takes a second to, download and run, but do you folks want me to give you a second to do all those things, or shall I move on? Can you give me a thumbs up to move on in the reactions? Cool. Okay, we're getting some positive feedback. Great. All right. Go ahead and speak up in the chat if you have any issues with the install, and one of us can hop in to try and troubleshoot. As we go. All right, so I'll be talking for a little bit, so go ahead and just let your code do its thing. Here are some of the background assumptions that I have in preparing this workshop. One is that you're here because you do at least some of your work with data using R, and more specifically that you're probably familiar with using the sort of tidyverse world of packages, and particularly dplyr and tidyr, or you'd like to be able to use those packages, and you'd like to be able to use those more frequently in your data workflows, because that's what we're going to be moving towards in this workshop, is using these kind of tidyverse style verbs with really big data sets. And that's the last point, that some of your data sets are too large to handle efficiently in R, or maybe you just can't even open them in R, because I talked to someone recently who had like a petabyte of data, which I hadn't really heard of, and I don't know quite how big that prefix is, but I was impressed. Great. And so what we're going to cover today specifically is we're going to talk about, and I mentioned this before, understanding the general landscape of tools that are available for interfacing with large data sets in R. And then we're going to look at using Arrow and DuckDB for storage and access of larger data sets. And we're going to be doing that with these like dplyr style pipelines. So we'll be using the dplyr pipe, if you're familiar with that. Well, actually, we're going to be using the pipes and verbs like mutate and rename and pivot, as you would if you were just manipulating a data frame in memory. And we'll finish up by talking about which tools are maybe going to be better suited to which types of tasks, and plugging you into a whole bunch more resources for how to get much more advanced and much more specialized with these different toolboxes. All right. So coming to the general landscape of big data in R. So here is a figure I made based on how I feel about things. So this is not a scientifically generated figure, but it's a general display of some of the tools that you're likely to see for interfacing with big data in R in this XY plane of how easy are they to use and interpret, and how big of a data set can these things really work with. So I'm coming into this with the assumption that we find dplyr and tidyr were pretty familiar and pretty intuitive to use, but that they're really constrained in that you can't use them with a very large data set. And that may be because you can't even open it in R, or because they're not really, they're pretty efficient, but in the sort of scope of ways a computer can interact with data, they are not optimized for efficiency. And so you can run out of memory or crash your computer using a complicated enough pipeline in dplyr or tidyr. There's other tools so data table can speed you up. It has a pretty opaque syntax. This is an R package. It has a pretty opaque syntax if you're not used to using it. And of course, these are going to be subjective. If you're really familiar with one of these and not familiar with another, what you find easy may or may not hold true for this, again, very scientific plot. And then we start to get into these different tools for working with potentially really huge data sets. There is always the option, which I suspect a number of us are already dealing with, which is just to do the really heavy lifting with some external program. Just do it in a database, do it in the command line, and then get your parse data into R, or maybe you're breaking up some really large data set into a whole bunch of little chunks and then running your same pipeline over and over again on each piece as you're able to load it in. There are other tools for connecting with databases, like formal databases through R. So you can use the DBI package to connect to a database. you can use the DBI package and the dbplyr package, which translates dplyr style verbs into SQL so that you can pipe them to a database without having to you don't have to know how to write the SQL command, because dbplyr will take your dplyr verb and do the translation for you. And we're going to be working a little bit with this today. But then most of the workshop today, we're going to be focusing in this kind of nice area where things are relatively intuitive to use and can be applied to potentially really huge data sets. And that's going to be DuckDB and Arrow, both of which look a lot like you're just working with dplyr, but can connect to arbitrarily large sets of data. So talking a little bit more in detail about these tools. So Apache Arrow here's what they describe it as. It's a cross-language development platform for in-memory analytics. And you can learn more about it at their website. What this breaks down into is that Arrow refers to a data format. There's Feather, Arrow, and Parquet formats, all of which you can learn more about them at that website. They focus on data stored, for our purposes, we'll say it's stored in a sort of column-focused format, whereas most traditional data storage formats are focused on rows. But that columnar data storage means you can perform sort of column-wise operations really fast, and you can avoid having to do this inefficient operation of pulling in all the rows when you really only need a single column. So it can do things really fast. It also has a bunch of libraries that connect with a whole bunch of different programming languages that you may be more familiar with, like Python or R is what we're going to be focusing on. And these libraries connect to functions that are built in much lower level. The R1 interfaces with the C implementations of Arrow functions to make it so that you can interact with R with these functions that are designed to work with data much more efficiently than R itself is. And there's a big emphasis in the whole Arrow ecosystem on interoperability. So rather than constraining you to use a particular format or a particular tool, the emphasis within the whole Arrow philosophy is on making it so that data stored or a pipeline built in one way can interface with another. And so what this means for our purposes is that an Arrow library can work with a whole bunch of different data formats. So you don't need to use a fancy columnar data storage like Parquet or Feather to get really good performance gains out of working with Arrow. So today we're not going to talk too much about those specialized data formats. If you want to explore more about them, there's some really great resources linked from their documentation. I see a question in the chat. Oh, the columnar format. Is the columnar format analogous to vector-based calculations? I don't know enough about how vectorization is implemented under the hood to know if that's a truly I don't know how far that analogy holds up. The way I would describe it is, and the way I've seen it described is say you want to filter on a particular column. If you have to load in all of the rows, so say you have a data set that's got 20 columns and 10,000 rows, and you want to filter based on column 1, if you have to load all 20 columns with 10,000 rows in order to perform that operation, you're doing 20 times more work than if you can load just the one column that you need to pay attention to and focus on that. There is more to, that's a gross oversimplification of how Arrow gets its performance gains, but that's a pretty high level of the columnar idea. Chat. Yeah, sweet. Yeah, it's fun to nerd out about. They have some really good explainers on the website too, that if you want to get more deeply into this and get probably a more technically robust answer than that kind of high level, I would go there. And so Arrow has an R library, which is what we're going to be working with. It's an R package that has bindings to the C functions underlying Arrow. And then the other tool we're going to be talking about today is DuckDB. So DuckDB is a database. It's similar to SQLite, if you're familiar with that. It's a little bit better for, it's built as a SQLite for analytics. I think I put that in there somewhere. It's an open source database format. You can install it using, if you install the R package, you will install DuckDB. So it's both a format and an R API. We'll be using the R API. Yeah, they build themselves as like the SQLite for analytics. They're a little bit faster for like processing things a lot of the time. And the thing that is really cool about DuckDB and why we're talking about it in the context of this workshop is that it can be a really powerful like add-on to Arrow, in addition to being a really powerful tool on its own. So you can use DuckDB and Arrow in the same workflow, or you can use either one. And they're very similar and they're very closely like, they have a lot of overlap. But the one thing that I will say now about DuckDB is that it handles relational data. So if you say you have like a system of linked tables, much more naturally than Arrow does. The stuff we'll be doing with Arrow today is really going to be focused on a single table. So that might be something to sort of put a pin in if your data involves like multiple tables, and that's something really important to handle efficiently. And so as I mentioned, DuckDB has an R API. There's actually now 2 ways to use DuckDB with R. We are going to be focusing on this first one, which is a DuckDB R API that goes through this translation step where it translates your code into SQL. And there's also now a DuckPlier package that skips that step. It is brand new. It came out like a week ago. So we're not ready to teach that yet. If you want to try it, it seems really cool. Hopefully we'll be able to advise more on it in the near future. And yes, in summary about the whole Arrow DuckDB situation, you can use either one or both. We're going to talk about using them separately and show how you can combine them to get the most exciting possible synergies. All right, so this is probably check in. How has anyone not been able to get the packages that we suggested or the data that we linked to downloaded and installed?
I'm still working with Ujal. We're still trying to get a Arrow installed on Windows.
That's mysterious. Everyone else, I guess, can you give me can I get a thumbs up either in the chat or as your like reaction if you have managed to get your packages installed and the data downloaded, you're able to get to an RStudio that's going to look something like this. So that you have an, oh, I need to share my whole screen with you, don't I? So we're going to be working in RStudio with an R project that's in that data download that I sent. So if you were able to download the data folder, you open that folder and you open bigdata.rproj and you should end up somewhere like here. I'm not hearing cries of concern, so I will proceed. So I just wanted to give a little bit of context on the data set we're going to be working with today. These are data that come from the North American Breeding Bird Survey, which is a community science project run by the USGS. Super short nutshell about it is annual counts of birds that are observed along like 25, probably more, 100 monitoring routes all over the US and Canada. And I think recently they expanded to Mexico. So these are going to be numbers of birds of each species that were seen in different locations around North America. And the data that I've sent are not huge. I think that there's a CSV file that holds all the data that's 70 megabytes. So we're not talking, these are not huge. I did this because I did not want to make us all sit here and download a 12 gigabyte file. But so they're big enough that if you do an operation in base R, you do an operation in Arrow, Arrow is going to be noticeably faster. But the things we do today, you could also do too with like million row data set, many row data set, and you'd still be able to get some pretty good performance gains out of it. So here's again a link to the download and a link to the source data file. I've done some summarizing, which just combining many stops into totals on this, but these are coming from this data repository. All right, so let's get set up to play with Arrow in R. So everyone make sure that you've managed to download the data and open that bigdata.rproj. And that should get you again to an R that looks something like this. If you open rscript.r, it should be empty and you should have a data folder with a couple of CSV files and a folder called Hive inside it. So the first set of packages we're going to need to use is going to be Arrow and dplyr. And as I said, there's also the TikTok package, which is for timing. It's for seeing how long functions take to evaluate on your computer. Not strictly necessary, but if you have it, it can be fun. So go ahead and load your libraries. And we'll get started with talking about loading data in using Arrow. And so throughout all of this, I'm mostly going to be showing and talking about commands as you evaluate in R. And you can go ahead and go to the link that I shared for these slides and copy paste the code, or type it out if you want, into this R script if you want to follow along. But I'm going to stop toggling back and forth between RStudio because it's going to be a lot of switching what you're seeing. All right. So first off, we can start by exploring what happens if we read a pretty big CSV file into R. So the CSV file that's located at data, and then there's that all routes, all stops.csv file. That CSV file is about 70 megabytes, and you can go ahead and copy this code to your computer. That tick is going to start a timer, and talk is going to like stop the stopwatch, and then it'll time how long whatever happens between tick and talk takes to happen. So you could copy paste this code. It's read CSV of the CSV file. And on my computer, this code takes about 4.5 seconds to load in the 70 megabyte CSV file. There is in the Arrow package a read CSV Arrow function, which is pretty much analogous to read.csv. It's going to find a CSV file and load it into an R object. And if we run tick and talk on that, read CSV Arrow takes about 1 second to do what read.csv in base R took about 4.3 seconds to do. So, and if we look at the, if we investigate what came out of running those commands, bird CSV, which is what we got from running read.csv, we've got what, 4 million rows, and we've got 5 columns. And bird's Arrow CSV, which is what we pulled in using Arrow, has exactly the same sort of structure at that level. So the read CSV Arrow is essentially a much faster version of read.csv. And the thing to be aware of with this one is it's going to help you read the data into memory, which will not help you if your data is too big for R to load. It is also going to read your data into a data frame that's pretty much the same as a data frame you read in using normal R, which means that you're still going to be like faced with all the same challenges that you'd run into if you were working with a really large data frame in R, which I don't know if you've got any of those memories haunting you, but things can crash or hang once your data frame gets pretty long. So the alternative to a read_CSV in Arrow is going to be this open dataset function. And we'll talk more about what the open dataset function is as we go along. But for here, I'm going to say it's not going to read it into a data frame. It's going to open a connection to that data frame, and you'll be able to, or to that CSV file, and you'll be able to write code to wrangle the contents of that CSV file, but it will not be happening in R's memory using R's machinery. It'll be happening using Arrow's machinery, which is a lot more efficient than R's machinery. So here, if we time just the connecting to the data part of this step, Bird's CSV using read CSV takes about like 4.7 seconds. This can vary. And open dataset using Arrow takes what, 1/100th of the time it takes to open the whole CSV file and load it into memory. And then let's look at what these what we've got when we run these two commands. So bird CSV is just the result of running read CSV and opening that CSV file. We've seen it before. It's got 3 million rows. It's got 5 columns. Same for this data set. We're able to look at the n row and the column names, and we've got the same number of things. Now let's look at what these data actually look at using head. So head, if you're familiar with just a regular data frame in R, it's going to give you the first 6 rows. That's what we've got. If we run head on an Arrow data set, that's not what we got. We get instead description of this table. It's telling us that we've got 5 columns, and head gives us 6 rows, and it's telling us the column types for each column, but it's not pulling in the actual data contents of that CSV file yet. And this is actually really powerful because what it is Arrow kind of understands what it's touching, but it's not going to pull it into R unless we need it. So it's able to touch it from a distance without loading it into our workspace and overloading like the actual workbench that we're working on. In order to get the actual data into R so that we can look at it, we need to add this function, which is collect. This collect function, which comes from dplyr, which is telling Arrow to pull the data into R's memory. And so once we add collect, we're actually going to compute all of the queries that we've run, or all the code that we've run on this data set so far. It'll all get computed, and the results will get loaded into R's memory. So in this case, we've computed just the head command, and then the results are getting pulled into R. And that's how we get this tibble that looks the same as the CSV file. Interesting. We've got some interesting stuff going on in the chat. So say it looks like your Arrow package does not support data sets. I'm wondering if you installed a much earlier version of Arrow? Oh, fascinating. Which operating system are you on? Because I've never seen that. On a Mac.
What R version?
Two Mac users. I wonder when datasets were implemented.
Let's see.
I'm doing some Googling about the error message.
All right, thanks.
Can you get, I'll just put it in the chat actually. Let's see here.
The code, when you had first mentioned the bringing in the 2 data sets, well, you're not technically bringing it in with Arrow, but the read CSV versus read CSV Arrow. Yeah, so, okay, so it's CSV. Okay, so then you switch the names, is that right, to Bird's Arrow data set?
Oh yeah, so yeah, I called Bird's Arrow CSV for the like read CSV Arrow, and then I think the name for the data set I assigned it as
Okay.
Bird's Arrow data set. Yeah.
Okay, so I'll fix that in my code.
No worries. It's kind of fast with the because I don't have to type it all out, so I'm not taking as much time. But it is. Hopefully everyone's able to get to these slides, and there's this little copy paste button here, which I mean, sometimes it's useful to write things out. For this, it's a lot of writing paths and things, so I would pedagogically encourage some copy pasting. There's a little copy paste button that shows up that can help you just get the code right into
Oh
your
yeah.
clipboard.
Look at that. I can't do data sets either.
What? I've never seen this.
Interesting.
Should we
Apparently 15.0.1 does not have, well, is that the same for everybody? So I guess this just depends on your.
You're on a Mac, right, Arrow? Right,
Mhm,
Eric?
mhm. Yeah, but my output, so a couple of folks have pasted in, there's an arrow function called arrow_info that'll tell you what your version of Arrow can and can't do. And mine, for example, is all falses except for Acero. Yours is like all trues except for substrate and a few others. And then the folks in the chat are kind of a mix of things. Oh no, I guess it looks like Jose is the same as mine, all falses. And Margaret's is also the same, but we're all using 15.0.1 version of the Arrow library. So yeah, interesting.
Drew has suggested that it's the M1 chip.
I am not on an M1. I'm on older architecture, and I still get that error. So yeah. I didn't think that this was new either.
Been using datasets for like 9 months.
Open data set. Let's see.
This there's nothing here about datasets not being supported. I don't know. So Anna's asking if this is an R version problem.
No.
No, yeah, it's
don't think so.
something about how Arrow, like it's not even right. You have Arrow 15.0.1, right, Eric? That's what you should.
Yep.
Yeah, so it's not even like the Arrow package version. It's something about what's turned on and off inside the Arrow package.
So I just installed Arrow and I'm on a Mac, and it for some reason installed version like 13 instead of 15. And I have trues for almost all of those options. Don't know why. So I don't know, maybe if installing an older version of Arrow might work.
I think some people are having problems. So if you look at Margaret's in the chat, she's got 15.0.1 and a whole bunch of falses.
That's what mine is also.
Jose's got 15.0.1 and a whole bunch of falses. They all have the Apple Clang compiler.
Yep.
And my compiler is the GNU. I'm on Windows. Well, this is interesting because I'm going to show you a whole bunch of stuff using Arrow datasets. And now I'm torn whether to just keep showing you a whole bunch of stuff with Arrow datasets and then email you later with whatever's going on about this, or just like try to figure this out. I think that I will figure out how to like adapt this for if you can't get Open Dataset working or to get Open Dataset working. And I will show you the rest of it because I have confidence that there is a workaround for this, but that it will take a long time to figure out right now. So if you can't get Open Dataset to work, sit back, relax. I'll follow up with an email once we get to the bottom of this. All right. Thank you for speaking up about that, because that is on, I mean, obviously, like, my computer has, and it's also not really in the, like, discourse, to my knowledge. Anyway,
Yeah,
This is
I was just looking, the data sets, the open data set thing was implemented in version 1 of the Arrow R package, and now we're on version 16. So it's not new. It's definitely not new.
Yeah.
I'll look around a bit, see if there's an
Thanks.
easy fix.
Yeah. All right. So you'll see all the results of running these commands if you've got data sets and data sets enabled as we go through here. So let's catch up. So okay. So we're talking about collect and how you need to use the collect function to tell Arrow to like do all this stuff to the data set and then bring me the result. And that collects the result and deposits it in your workspace. And so that's when you get something like a tibble that looks the way these data are supposed to look. And that is where your code will slow down or hang, or like that's when like the heavy lifting happens, basically. And so thing to understand about open dataset when it's working is that it connects to the data, but it doesn't pull it into memory. It does the computations using Arrow's C library, and to get the results into R where you can touch them and look at them, you need to use collect. Arrow also has really nice support for this concept of Hive partitioning, which I want to talk about. It may be intuitive, it's certainly not only for Arrow, but it can help you work with a big data set, and it can help you make something more portable. And so the Hive partitioning is basically, so for these data, there is a column called, I'll show you in these data, there's a column called state number. And this is for, there's more than 50 states. It's all the states in the US and then also, I guess, provinces in Canada. So there's a whole bunch of states. And what the Hive partitioning does is it allows you to break a really big data file or data frame into a whole bunch of smaller files based on variables. So in this case, it's broken it into a different CSV file based on each state number. And it can then divide them further. So you can have part 0. And if that were to be like thousands and thousands of rows, it would max out and say, okay, part 0, part 1, part 2, part 3. And Arrow is really good at taking a data set that's in a big, long, chunked together data set form and breaking it into something like this, or at reading in data that is stored in a structure like this. And you can do this using the open dataset function again, where instead of giving it a file path to a specific file, you can give it a path to a directory, and then tell it which variables it's partitioned by. So this data set, the directories contain state number equals 2. And if we tell Arrow that it's partitioned on state num, it'll read these data in, and then based on the directory names, create the state num column again, so that it recombines into the same data set. And so if we were to run this code, we get the birds Arrow Hive. It still has the same number of rows, and it's got our same column names. It does move the partitioning columns to the end, but you've got the same data otherwise. And so this can be really useful, especially if you need to do something with portability. So like a really huge CSV file is hard to move around. If you've got it split up into a whole bunch of smaller files, it can be easier to share. The downside of that is that you've got a million files and you've got a really long set of directory names, which means that you will either be doing a lot of pasting together directory names, or you'll be using functions like open dataset and Arrow that are set up to handle all of that under the hood. Okay, so we can do a little bit of playing with dplyr style pipelines in Arrow. So if you haven't already, go ahead and load dplyr in. And we can start playing with some of these familiar dplyr verbs on our data set. So this is a little dplyr paragraph that's going to take our big data set that has all the birds we've ever seen in North America and filter them to state, and the state for Arizona is 6. So you can get the Arizona birds if we filter it to state number in Arizona. And if we select state number and root, we're going to pull out the state number column, and then the root refers to like the location, like the site in the country where we're doing this surveying. And then distinct is going to filter those to unique combinations of state number and root. So this is going to give us a list. Oh dear. Oh dear. It's going to give us a list, as I navigate back through my slides, of all of the roots in the state of Arizona. And if we look at the head, we have a tibble, and it's got its columns for the state number and the root. And so the basic structure for a paragraph like this is you can have your arrow data set, and then you string together a set of dplyr verbs with your little pipe. You can string together a whole bunch of data wrangling commands, and then at the end, you just run collect, and it'll pull all of those results into memory and give you the results in R. So getting more playful with this, you can use mutate to paste column names together, get yourself a unique root name identifier. And again, you need that collect.
Can I ask a question, Renata?
Yeah.
I was wondering, so when you were saying that this is like something about C libraries, I got a little, I mean, this, I don't really need to know the details, I guess. I'm pretty, a lot of us are very familiar with the dplyr commands, but when you're using a dplyr command on this data set that's not in memory, like what's actually happening? Like how does that work?
So Arrow has bindings to a bunch of, not all, but a bunch of functions in base R that essentially, as I understand it, and I'm not like a C developer at this level, as I understand it, it translates the like dplyr operation into the C implementation so that like it's a, they're like a, it's like a, it's has an implementation for filter that connects to Arrow. So you're not actually running like dplyr filter under the hood.
Yeah,
It's
that's
like,
what I was thinking. Like it can't possibly be the same filter as you would use on like a data frame because it's not present
It's like-
inside your computer, your R memory or whatever it is.
yeah, the way I think of it is like an alias almost. Like it's a function
Okay.
alias that implements the dplyr function,
Okay.
the analogous one in the Arrow libraries. And this does become important because not all the functions, not all dplyr functions, not all base
Uh-huh.
R functions have these bindings.
Okay, so
And
only some of maybe many of the most popular ones, but only some subset of them work in this
yeah,
way.
only some of them work. And we're going
So-
to talk about
Because it's
Yeah.
like things like your mutate. It's like, yeah, the mutate is the dplyr function, but then inside your mutate, you might be using any number of other R functions. It could be, from other packages. I was just like, how does it know? How does Arrow know how to?
Yeah, so it
Somehow-
knows because somebody gave it a cheat sheet.
Okay.
And if it doesn't know, it will complain. And
Okay.
we'll see it complain soon. And that can be, yeah, it can be a little bit, there's a little bit of finesse to doing this because of that.
Very
Yeah.
cool though. Thanks.
Yeah, thanks it's a great question. So yeah, and actually here's an example of exactly that. So here we try, so this is trying to do a group by summarize style operation on this data set. So let's say we want to group by state number and root and then find out how many years we've got data for each root and how many species we've seen along that route. And so this is at least my coding habit from grad school, is like to get the number of unique years in a data frame, you would do length unique year, right? And so I write my summarize, and years is the number, like the length of unique values in the year vector. And I get this error that says error, expression length unique year is not supported in Arrow. And it says call collect first to pull the data into R. And so this is exactly the kind of thing that happens, Jessica. So what's happening here is Arrow doesn't know what length unique, like length nested and unique means, because there's not like a implementation for that. In this case, so yeah, not all the functions are supported. In this case, there is actually a function that I think is also like probably what a lot of people use for this specific case, which is ndistinct, which is does the same thing, counts the number of unique values. It does have an arrow binding. You can use that and it'll be perfectly happy. A couple of slides down from here, there's going to be a link to the dictionary of which functions have these kinds of mappings into Arrow. Yeah. Joins. Is going to get us into a whole other kettle of fish. So you can do joins in Arrow, and here's us attempting, here's a means of attempting to do that again. So we can read in the CSV file that has information on the roots. Since I'm not sure how many folks are following along, I will pull this into my memory so you can just see it. Well, it's showing up as an object containing active binding, but call names on root info. It's got its information that has like state number and root, and then it's got information about like the latitude and the longitude and the country that it's in and stuff. So it's kind of metadata about different routes. Yeah, sorry, and I can slow down for a second. So this is an example of if we're wanting to pull multiple tables in and then join them as you would using like a dplyr left join. And we looking at these two tables, as I showed you, roots is going to have these state number and root columns that should make it possible to join it to the birds arrow data set, which also has, if we look at it, the state number and the root columns. But if we try to do this left join, we get an arrow, or we will get an arrow. Oh my gosh. An error about incompatible data types for join field keys. How are folks doing? Are we can you give me a thumbs up if you're trying to follow along with the code? So not if your data sets are not working and you're caught up. Getting some thumbs up.
Repeat, I think I was scrambling to copy and paste a second ago with the arrow table. So the read CSV arrow, I was like, we've seen that before.
Oh yeah.
What's the arrow table?
So if you were to read this in, if you were to only do the read CSV, I'll show you what happens. You'll get a data frame, and that's a data frame in memory. And Arrow actually doesn't like trying to do something like join a data frame in memory onto like an Arrow data set, because the Arrow data set, if you look at them, they're objects containing active binding. They're not data frames in memory, and Arrow can't connect those. And so what the Arrow table does is it makes the data frame that's in memory into a table object that it can like interface with the data set. That's a good catch. So yeah, but we still can't actually join these two things together, because if we try to join these things together, we get this error about incompatible field types. And what's going on here is Arrow is really strict about the schemas or data types in which it's like assigning to each column, and it'll guess based on, honestly, to my read, a little bit like, I often don't agree with its guesses, I'll just say, about what's the best data type, or the best way to read in a given column. And so in this case, it's read in one of these as an int 32. This is a 32-bit integer, and it's read in one of these as an int 64 or a 64-bit integer, and it doesn't know how to connect those two things. They're the same numbers, by the way. It's just decided to do it differently, right? So we can start to, and this is an issue that I have encountered a lot in working with Arrow, and so figuring out how to work around it is worth taking a second. We can start to debug this if we use the schema function in Arrow which will show us Arrow's schema or how Arrow is understanding the data set to be structured. And so if we run schema on the bird's Arrow data set, you'll find that it's using int64, so a 64-bit integer, to store all of the variables in this data set. If you run schema on this root info table that we've loaded, it's using int32s. And this is our problem, is that we have two columns that we would like to join on that are being stored in one data set as an int32, and the other data set has them as an int64. You can modify a schema. So you can create a schema object. And so the fastest way I know to do this is to just run schema on a data object. You can also create them by like handwriting them out, which is inefficient for any number of, if you have any kind of number of columns. And then this root schema is going to be kind of like a list where you can reassign the data type for different columns in the data set. So we can manually modify the root schema and tell it that we want the state number column to be an int64 and that we want the root column to be an int64. And then we can read our CSV table in again, or our CSV file in again, and when we supply the Arrow table, we say, and I want you to use a schema that is this root schema that I've created and modified. And by providing this schema, we will overwrite whatever Arrow is going to like guess should be the data type for each column and tell it specifically which data type to use for each column. And when we do this, and then we look at how the different variables in root info are being stored, everything that we didn't change is still being stored as an int32, but the two that we said specifically needed to be an int64 have been loaded in as int64. And so now if we go back to our join and we've modified the schema for the root data frame, or the root info table, sorry, we can run left join and it's got the data types linked up properly, and we should be able to stick these two tables together with no trouble. This is, I hope this concept is much easier for you than it was for me. I definitely like had to go down some rabbit holes to get this. So how are we doing with this?
How does it know when it just first, when you read it in? What, like, how did it decide to assign it 32 in one case and 64 in the other case? Like, can you just
That I don't
tell
totally
it
know.
somewhere? Like
You
when you're
can-
reading it in?
You can, so this time when you created the Arrow table, you can provide it with a schema.
Okay.
You can also provide a schema in Open Dataset.
Okay.
I showed
You
it
have to
this
like
way.
create it. You can't like for the whole thing, which is like non-trivial to do when you have like a whole bunch of, you can't be like,
Exactly.
oh, by the way, column 2 needs to be a 64-bit and that's it.
Yeah, there are
The other ones
so
can be defaults.
yeah, you have to, so to modify things using like modifications to the schema, you have to provide like a complete schema. You can't just like say like some of the like data import packages in R, you can be like default character,
Yeah.
but I want this column to be a date or something.
Exactly. I was thinking along those lines. Can you just like cheat and say default everything except for these two columns? But no,
I
not
honestly
apparent.
have not been a fan of the documentation for working with Arrow schemas. It's a little bit thin, which is why I showed this. There are some functions for, depending on what types of data you're reading in, you can use like, sometimes you can pass options to like read delim that might give you some of that control. I have not found it to be terribly consistent or teachable.
Mm-hmm.
But there's some hope in that direction, but it's a lot more like finicky than just like, yeah, reading a CSV file in as you normally would.
Thank you.
Yeah, great question. All right, we're almost to a natural breaking point, and I do want to give us a break. So one more thing I wanted to show that is also going to illustrate funny things about how Arrow works is the idea of a window function. So this first paragraph of code is actually not doing the window function. It is just going to get us a column that is like the total number of birds that we have observed on each route in each year. And then the window function of this is going to be trying to get, these are something called like the lag and lead functions in dplyr. So the lag function will look at one row, and then it will look at the value of that row, the value of that column in the previous row. And so it's for something if you want to look at like a time series. And in this case, it's for asking, how many birds did I see last year? And creating a column for that in this year. And so this is something that you'll see a lot again in working with time series. You can also see it if you want to do any kind of differencing. And these are functions that are really great and powerful and implemented in dplyr, but Arrow cannot do. And so if you try to do a lag function in Arrow, you're going to get this error of lag total birds is not supported in Arrow. And this is one that does not have any kind of analog. So the other workaround, if there's not an arrow binding, which is not an ideal workaround, is what it's suggesting here, which is to move collect earlier in the pipeline. So if you move collect earlier, so if you move collect, so it happens before you try to run the lag function, essentially what you're doing is you're doing all of the calculations prior to the collect using arrow functions. Then you load it into R as a data frame, and then you can proceed on your way with the non-supported functions. This can be great if you need to do something super specialized and you can't do it with Arrow. But the downside of this is when you get to that collect step, you are going to hit the bottleneck of what your R session can handle. So if you're able to do any amount of, in this case, filtering, grouping, and summarizing to make a really big data frame into something tractable, this can be a workable pipeline where like you have some massive data set, you filter, you shrink it by filtering it or grouping it or summarizing it, and then you can pull it in and do the rest of your work in normal dplyr. This isn't going to work if your data set is still way too big to do this, or if you can't shrink it before you load it in. And another set of things, so this can be a workaround. And then last set of things that I think we all sort of encounter in our lives is this idea of reshaping data, which is another one that is not going to be natively supported in Arrow. So here, if you try to load in library tidyr, and then try to pivot this data frame wider, in this case, we're pivoting to get sort of a, if you're an ecologist, kind of a site by species matrix, which is going to have a column for each bird species and a value saying the abundance of each bird species. That pivot function isn't going to work in Arrow. So to summarize this whole like sort of dplyr adventure in Arrow, many dplyr functions have bindings to Arrow functions that will let you like do them in Arrow like magic. Some of the ones that don't have very close cousins so that you can like fiddle with your code a little bit and make it work. And then some are straight just not implemented and won't work. And sometimes that's like they can't be implemented and sometimes they're just not. And if you want, and I highly recommend this, there's a data wrangling vignette as part of the Arrow R package, which will go through all of this in a lot more detail. And there is a kind of dictionary of supported functions that you can use to write. This is like your dictionary of things you can use to write Arrow pipelines that look like dplyr code. And we are at an impasse with functions that are not supported and don't really have a reasonable analog. But that's where we're headed next. I am going to give us a pause now. It's 12:03. I promised you a break at 11:50. So let's go ahead and break until 12:13. Go get up, walk around, get some coffee. I'll be in the vicinity if anyone has any questions, and otherwise, we will see you shortly. So yeah, so as folks come back, we're still trying to troubleshoot the dataset install issue. I think we found one other human who had this issue. I think so. Here's like this is the bug report section of GitHub for Arrow. I think we found another person who has this issue where they're installing it and then they're getting all of your capabilities showing up as switched off. We're still going down the like rabbit hole of like what happened there. Reading this case, it looks like there was like an issue with their Xcode installation, which is like compiler, command line and compiler tools for Macs, which is, I hope it's not that, because that's hard, you know, it takes a long time to install. It looks like this
They
is
also
like this...
recommend.
Oh yeah, go
the-
ahead. Oh,
I see that they also recommend installing it from RUniverse, which I'm trying right now. I'll tell you if that works.
Awesome. Yeah, thanks. Yeah, this is it looks like it's kind of a niche thing. I mean, it's going to affect a
Yep.
lot of people, but it's also like
The RUniverse version has data sets enabled. So I'll paste that into the
oh, fantastic. Thank you so much.
into the chat. That does it.
Fantastic. All right. Thank you, Eric. So it looks like the answer is we need to install it from RUniverse right now instead of CRAN.
That might also be something, Ujjal, that you could try for I know you're having problems on Windows. It might be worth a shot running that code I just pasted into the chat.
Okay.
You might just like the Zoom chat changes quotation marks into fancy ones. You might have to like fix those. I don't know. It does that sometimes. So
Great. So, where did we leave off? We left off, we tried to do some reshaping in Arrow, and we can't do reshaping in Arrow, which is pivot wider, pivot longer. We can't do that in Arrow because it's not implemented in Arrow. I said, stay tuned. So this is where, this is like one of the biggest use cases for me for pulling Arrow and DuckDB into the same workflow. So as a quick reminder, we talked about this at the beginning, DuckDB is a database format engine, all these things, and it has an R API. So it's a way to, it does things in R. It's similar to Arrow. It's got this kind of under the hood implementation that translates R code into DuckDB. Combining DuckDB with Arrow is awesome because the DuckDB API can implement some functions that Arrow can't. Oh, I think I saw in the chat that it works. Fantastic. We love to see it. So DuckDB can implement some functions that Arrow can't. And you can sort of shuttle data back and forth between DuckDB and Arrow to use functions from either toolset without a lot of additional overhead. So in the way that if you were to load your data into R using collect, you would then be like running through this huge memory bottleneck of loading this big data frame into R. You don't run into that same problem if you just like pass it from Arrow to DuckDB without taking it all the way into R's memory on the way. And we do this with a function, it's an Arrow called arrow to DuckDB. And we can embed this function in a code chunk like so. So we have our birds data set. And you can write some code to, again, like here we're filtering it to a particular area geographically. We're pulling out some columns, and then this arrow to DuckDB command passes this arrow dataset object into cans it over to DuckDB, and then we can write this pivot wider function, which is some tidyverse syntax to make this into a table with a column for each species and a row for each year, the number of individual birds seen in that year. And just as we've been doing with all the other Arrow pipelines, then we can run collect and we'll get our data frame that's been pivoted wider. And so for sort of at the user level, embedding this to DuckDB function allows you to pretty seamlessly sort of expand the set of things that you could do with Arrow by everything that you can also do with DuckDB. And it feels and looks very similar to as if you're just using Arrow or as if you're just using dplyr for in a lot of ways. This is not, so DuckDB can also just be used entirely outside of Arrow land. You don't need to deal with Arrow to use DuckDB. And this may be the right workflow for you. And yes, Jessica's asking if, I assume you installed DuckDB and now it wants you to install dbplyr. Yeah. Yeah, so DuckDB is using dbplyr to translate dplyr looking code into this kind of SQL dialect that DuckDB understands. And yeah, dbplyr will also do that same translation for a whole bunch of different backends, like, I mean, SQLite or a whole bunch of other things. Here we're using it with DuckDB.
So that has a much broader array of, I guess, bindings or whatever you call it, like the translations
I guess
of
I
the
would
dplyr, or
I don't know the full scope of like everything that's implemented in DuckDB versus Arrow. I have found that most things that are implemented in Arrow are implemented in DuckDB.
that
The
aren't
downside,
implemented in Arrow.
they are implemented in DuckDB, yeah.
Okay, great. So aren't in one, aren't in Arrow,
Yes.
are in DuckDB. Okay, cool.
Yeah, the downside of DuckDB is if you want to like store DuckDB objects, the fastest way to do it is as a DuckDB database, and then you have a database instead of like CSV files or whatever other files you have, and you have a DuckDB database that you have to like handle
Okay.
as a database, and it has attributes like for example, like it's difficult to modify the tables once you have them, or once you add data to a table, you can delete the table, or you can delete the, so like once you like add rows to a table, you can delete the rows, but you will not get your disk space back. Because you deleted the rows, but like the footprint of the table in memory did not shrink to like reflect that you deleted those rows, and there's just no way around that. So you have to be careful about what data you ultimately sync into a database, like a DuckDB database.
Okay, so it's like the advantage, you're like, okay, now many more or almost all of these functions, these like my favorite dplyr tidyverse functions now work, but it's like requiring this different format that requires a bit more thinking or caution compared to Arrow.
Yeah,
Understanding that correctly.
Yeah, so that's why you would often like, that's why I would like often like maybe do something. If I don't want to be using a database, I could do it all in Arrow and then use that to DuckDB to like put on my DuckDB hat real quick and like do a thing with DuckDB, and then like take off the DuckDB hat and like still be able to be in Arrow land, versus just doing everything within DuckDB.
Gotcha. Thanks for clarifying that. Yeah, that's a nuance I wouldn't have never have guessed on my own. Thank you.
Yeah, it's definitely like different ones are going to work better for different use cases. So yeah, so using DuckDB on its own, you can use DuckDB to wrangle data that's like stored in these different formats. Or as a DuckDB database. It also, unlike Arrow, and I'm happy to talk more about this, you can configure it to load data that's like living somewhere on the internet, whereas Arrow, you can't do an Arrow dataset that's like, yeah, DuckDB can like touch data without downloading it, I should say. You can get data into a database without first downloading a CSV file, which can be powerful. And unlike Arrow, DuckDB is a database, so it's going to be very naturally set up to handle like multiple related tables, and it'll have all of the constraints that you get with a database. So it'll keep track of once you've got tables created, it will enforce consistency on them. And so that can be useful for you if like that's what you're working with, but if it's not what you're working with and it's not what you need, it can be a lot of additional constraints on what you can do with your data, and it can make things more complicated. So as I mentioned before, there are multiple options for working with DuckDB in R. What I showed today is all going to be this DuckDB package, which is integrating with DBI and dbplyr, which are two kind of general use packages for connecting to databases from R to support dplyr verbs. And what these packages do, what dbplyr does, is it translates dplyr functions into SQL dialects that can communicate with these different database backends. There is also the duckplyr package that I mentioned is brand new, that's going to go directly to DuckDB without going through that SQL translation stage. But it's so new that we're not ready to teach it yet. All right. So if you were to be using just DuckDB and not Arrow, you can do something very similar in it's like you can load data from a CSV file into DuckDB and it will still keep it outside memory. But there's a little bit more setup to using a workflow like this. You're going to need the DuckDB package and then the DBI package, because what you are going to do is create a DuckDB database. And in this instance, you're going to create kind of a temp or an ephemeral database. You're not going to store this as a file. It's just a connection that DBI and DuckDB are going to use to sort of like, but it's not going to store it permanently on your machine. You can also provide like a file path here that ends in DuckDB, and you'll store it as a database in your computer. And so you need to create this DuckDB with just DuckDB, and then this DB connect function comes from the DBI package, and it will connect to this empty database and create this connection that we're naming con. And you need this connection so that you can perform all of these DuckDB dbplyr functions. And so in order to get data into your like DuckDB space, you can use this DuckDB read CSV function. There's other functions for other data types. And we provide this connection to the DuckDB con, this temp connection that we've created. Provide a name, which is going to be like the name of this data table within the DuckDB database. And then you can provide it files or other, there's different ways you can connect these files. Here, we're just giving it a path to our big CSV file. And then, so this code is going to read the CSV file and store it, or store the CSV file in the DuckDB connection space for our purposes. We can then use this anytime we want to access a data table that we've got inside a DuckDB in a DuckDB. We need to use the tibble. I'm not really sure how to say this actually, but TBL, and this is a dbplyr function that's going to take a connection to a database and then a table name. So if we do table, we're saying we want the all routes, all stops table in this database that we're connected to via this con. And let's just look at the head of that. And this is going to give us the first 6 rows of that table that are stored as a DuckDB. So critical thing for doing any kind of dbplyr function with DuckDB, use tibble, or I'm going to say it tibble, and specify the table name. And then under the hood, DuckDB and dbplyr will work together to translate whatever dplyr verbs you give it into the correct database, like syntax under the hood. So an example of this is we're using that tibble syntax to connect to the all routes, all stops table in our little temp database. And we can string together these dplyr verbs. So we're filtering to, this is Arizona, and then we're going to group by state and route and get the unique numbers of states and routes. And then we're going to count up how many, years and species we have for each location. We already did a very similar thing to this in Arrow, and we get our same summarized data frame out through this pipeline.
There's a question in the chat from Andrew. Could you explain why reading in a CSV using DuckDB read CSV is much faster than read.csv? Curious
Magic.
what's going on behind the scenes.
Magic. So no, there's actually, they worked really hard on that, and there's threads about it, and I'm not quite the one to like summarize those. One of the things with DuckDB is it's much faster than even other like databases, that kind of thing. I think if I'm understanding the question correctly, it's not, so I will say it's not, so DuckDB is faster than other things like reading and translating, and then read.csv is going to be pulling it into R's memory. And the DuckDB read CSV is doing something analogous to that Arrow open dataset, where it's not like if you imagine that CSV file is a big heavy object, and you're having to like read CSV, picks up that big heavy object and sets it down on your desk to work with it. And it takes a second to pick that thing up and put it on your desk. DuckDB is going to connect to that object. It's going to like reach down. It's going to like run its fingers over the like edges of that box. It's going to get a sense of what's inside, and it's going to create a channel to it, but it's not going to pick up the whole thing. And so then when you run this like these like pipelines on it, it can like riffle through that box and like pull out certain files and like do a whole bunch of stuff, and then bring you back the results of all that fiddling around without picking up the big heavy box, setting it down on your table. So it's saving you all that work, because it's doing a whole bunch of the fiddling with the box still on the floor.
Does it
Not sure if that
now-
metaphor was helpful. I kind of figured it out as I went.
I enjoyed it. But is this creating a database object somewhere?
Yeah, there's like a duckdb.temp hiding somewhere that'll get deleted when you disconnect from it.
Okay, so it's not a permanent, you haven't like permanently put your CSV into a database object unless you save it out that
Yeah.
way. So- okay.
You
Very
can.
cool.
So if you were to, at this stage, when you create this DuckDB, that DuckDB, nothing in the parentheses, if you supply a path to something that ends in .duckdb here, I should show. I'll show you the help page for that. You have the option to so there's a DuckDB, that should be bigger now. If you run that DuckDB function and provide a dbdir argument, you can say like my duckdb.duckdb. And yeah, it's giving me errors because I'm kind of out of sync with my updates. But it's created this my duckdb.duckdb, and it's tiny, it doesn't really have anything in it. And then I could connect to this database. And I could say like I could make con to this. I need to put that in quotes. I did. Oh, well, it's not happy right now. Anyway, I'm getting off track here, but you can create. And
Yeah,
save a
sorry about
DuckDB.
that. I didn't
Yeah,
mean for
no,
you
you're
to.
good.
Yeah, it's just.
Yeah, you can
So
create
just
and
you
save a
can
DuckDB.
make an object, or it can be a temporary, just using this as a way to use the various dbplyr functions
Mhm.
and not load things into memory, but you don't actually have to
Mhm.
create it as a database object.
Yeah.
Thank you.
Yeah, so you can do, let's see, you can do your dplyr pipelines. You can do, and yeah, so here now you can do your pivot, and you don't have to shuttle back and forth between Arrow and DuckDB. You can just embed that reshaping code in there. You need that collect to pull it back in.
We're on your
And-
RStudio still.
Oh, I'm sorry. I thought I'd
Nice.
given you my whole screen. I will come back. Yeah, so here's code for doing that same pivot operation that we did earlier by shuttling back and forth between Arrow and DuckDB. This is doing it entirely in DuckDB. You can run all of this without running collect until the very end, and then look at the first few rows, get a whole bunch of columns because there's a lot of species of birds. But this will work without any additional passing of data around. Last thing that I think is good to know about using something like the DuckDB engine is that you don't have to use the dbplyr dplyr syntax. And this, I'm going to show you kind of a trivial example, but this can be really useful if you have more, if you have something you need to do that you can't figure out how to do within the sort of sandbox of dplyr and dbplyr. Because I kind of think of like dplyr, dbplyr is like, maybe it's like the sort of prepared food sections of the grocery store, and like that's great if you just need to like, maybe most of the time you just need to like make like a box brownie mix and you don't need like specialized ingredients, and it's so much faster to just get the box brownie mix, right? There is a way to go get all of the raw ingredients, mix them together, and make your thing. And you can do that in DuckDB by passing raw SQL commands to run on DuckDB. And it's worth knowing how to do that, at least at a high level. So anytime you're running a dbplyr style pipeline, what's happening under the hood, as we've mentioned, is you're writing your dplyr code, and then dbplyr translates that into a SQL command that's like appropriate for the database that you're connected to. And so that means that there's a literal like command that it's writing, or that's creating and running, and it's just hiding that work from you. But you can get it to reveal this work and to reveal to you the command that it is using this show query function. So if you embed show query in a pipeline of text, instead of running the query, it will show you what it's communicating to the database. And this can be really useful. Sorry, there's a truck going by. This can be really useful for debugging, and it can be really useful for if you need to do something that there's a way to do it in SQL, but there's not a way to do it directly in dplyr. And so you can use this show query, or if you're comfortable writing your own commands, you can write your own commands and store it as a character vector, just a string, an R, or sorry, not a character vector. Misspoke, store it as a string. And then you can use this DBI package to evaluate a literal query. It's a literal bit of text as a query from R. And so for this, we want to get the results, so we can run db get query and tell it where our database is, and then provide something to the statement function, or the statement argument. And this is that string of text that we copied over from the last slide. And so the query that we wrote, or that I wrote just before, is this pretty trivial filter that we could do in dplyr. There could be instances, and I didn't want to get too derailed with those right now, where that query is something more specialized. You can do this, it can be specialized. I've done it in order to copy data and sort of get around some of the built-in defaults for like guessing data types. I wanted just to copy it over literally and not try to tell me what the data types were going to be. And the built-in functions had these defaults set and I couldn't change them. If you write the raw command, you can get around that. So if you want to get more involved under the hood, or you have something you can't figure out how to do in like tidyverse land, you have this workaround. It's harder, it's more work. You have to get familiar with the SQL code, but it can really open up what you're able to do while staying within R. And last up, anytime we're working with a DuckDB kind of thing, you do want to disconnect from that database. And with DuckDB, I find, so you run this DB disconnect function. And with DuckDB, I do find it's good to also turn the shutdown option to true. Default is false. If you don't do this, and then you try to touch that database from another R session, if it hasn't disconnected and shut itself down, it won't be able to connect to that database because the DuckDB format can't have more than one, like, it can't be connected, it can't be opened by more than one thing at a time. And that protects it from like getting confused and overwriting itself, but it also means you do have to remember to do this. It'll happen if you shut down R completely, but if you're working in like multiple R scripts or have like, I don't know what you may have, Cordo documents, functions that are connecting to each other, you want to keep yourself cleaned up after yourself in these pipelines. Great. In summary, thank you for going on this journey. Here's a little bit of an overview. Oh yeah, I'll answer this question. Advantages of using DuckDB over another SQL database such as SQLite. DuckDB has a lot of hype around it right now. It's new. I think it is a lot faster for some things. It's got this Arrow integration, so that's why I taught it here, because it has this like very nice integration with Arrow, and it's also has this like other alter, other alter life as a database engine on its own. I would say if you're already using SQLite for something, I would not like change to DuckDB. But if you're doing something that's like starting fresh, it's worth exploring. It does also, depending on, I'm not sure if the HTTPS, like the remote connections, work with all of the possible backends. And I'm not sure, like, yeah. And DuckDB now does have DuckPlier, which is this like direct, do not go through dplyr, no SQL translation step, which might be a really big game changer. But yeah, the other engines are also probably great and fine, especially if you're already set up to use them. As far as choosing your tool, so this is like not a comprehensive comparison chart, but a high level for like how I've thought about it and how I think about it in the context of this workshop. Arrow is especially good if you're going to focus on one big table. It can get a little bit more fiddly if you have multiple different tables, because they're just going to be stored, like they're going to have their own directory. DuckDB is good if you have multiple related tables and you want to keep them together in a true relational database. Arrow and DuckDB have this kind of dplyr heavy workflow, and you can expand that if you use DuckDB and DBI to get to this more customized SQL, artisanal commands. And the real like dividing line on these is also this like interoperability question, which is like, if you're willing to like move things into a DuckDB or deal with database connections and all that, DuckDB has a lot going for it. But if you need your data to be like super interoperable or like stored in these like very common formats like CSV or Parquet or Feather or whatever, Arrow is going to do that a little bit better. None of this is like set in stone. You can always shift something from a DuckDB. You can export that to CSV files. You can move things around, but as far as how things are going to be set up with the least friction, this is how I think about it. And one of the really cool things about this whole ecosystem is that you can shift between different tools depending on what different parts of your workflow are needing. And especially between Arrow and DuckDB, there's a lot of like really like, I think the developers are kind of working in this kind of synergistic way to make these two tools work together, which can make it really great and flexible. You have a lot less redundancy and a lot more interoperability, which I appreciate. I want to leave you with some resources for getting more information on all of these. For Arrow, there's the Apache Arrow website, our package. All of these links are in the slides that I shared. And I already showed this list of the supported functions and here is a really great actually tutorial on Arrow that was given at the POSIT-Conf in 2023. So if you want to do a whole bunch more than we did today, working with some truly huge data sets in Arrow, this is like a 1-day workshop worth of material, written and presented by some people who work on the Arrow package. So I really recommend that. For DuckDB, these first 2 links are links to the DuckDB site and the documentation for the DuckDB R API. Here's a blog post that I've enjoyed for connecting to data that's stored remotely on the internet somewhere. And then here is a link to the new DuckPlyer package if you wanted to explore more about that. I will certainly be exploring more about that. And more generally, stepping back to talk about our group and opportunities. As I mentioned, we're available as a resource. We have drop-in hours every Tuesday from 9 to 10 a.m. on GatherTown, and you can find more information about that on our website. We're also able to work with you in different ways on incubator projects, which are these kind of like focused, like if you have a project and like, it'd be really great to have a person whose entire job it is to do this stuff, to do a data intensive or computationally intensive project in collaboration with you. We're available for that. We also do have workshops coming up this summer. We're going to be running a series on ggplot2, I believe, so stay tuned for that. And there's also lots more resources beyond our group at UA. There's ResBaz, which is there's a conference/unconference coming up in May, and also just a community that's active year-round. There's Coffee and Code, which happens every Wednesday, Hacky Hour, and the Data Science Slack. And if you want to get connected to any of those resources, you can reach out to us, and we'll be happy to get you connected. Or you can sign up for the Slack at this link. And the UA Libraries also has data and visualization drop-in hours, which I believe are in person these days, if you prefer that. And the Data Science Institute also runs a lot of workshops and trainings as well. So we have a little bit of time. That's all the material I'd stored up to show. If you want more details on anything that I talked about that our group does, please check out our website. We would also really appreciate it if you could fill in the survey about today's workshop. That helps us make these workshops better and more useful for you. I'll drop the link in the chat. Yep. I'll send the link to everyone in the chat. And otherwise, I'm available. We're all available to chat more about this. If you have any questions, we're really glad you came. Thanks so much.
Oh my gosh, Eric, how are you doing those backgrounds?
New Zoom version. Update your Zoom, man.
Oh, that's right. Someone updated their Zoom. I was in a meeting with somebody a few weeks ago or something, and like when they would like do thumbs up on their camera, it would like make thumbs up appear and stuff.
I could not figure out. Yeah, I suspect it's a bug. I found an old issue from 2022 that's somebody having the same problem, and it never got resolved or anything. So I just made a comment on it and said that I just had somebody have the same issue. I sent you the link in the chat. So keep an eye on that. And I don't know, maybe Renata, like I don't have it's also hard for me to diagnose because I don't have a Windows machine, and so maybe it's something that you and Renata can chat about offline.
What was your You had the DLL issue, right?
Yes.
Yeah,
I think I found.
might
I think I
be.
dropped it in our. Oh yeah, because that was
Might-
different. Sorry, I had like presentation brain and like put
Yeah.
it in some weird like place, but
It might be this issue that I just pasted in. I mean, somebody else had the same problem, but there's no solution there, so it's not very helpful.
did you have the don't use? Okay, yeah, I found this too that they seem to think was not a long-term issue, but yeah, it's something about it's being able to find it on your machine.
Okay, yeah.
So I don't know if you
But
want to come to drop-in hours or something, we might be able to like, because my computer doesn't, I can't reproduce on my computer either.
okay,
So
Yeah.
we'd probably need to work together to like figure out what's happening there.
yeah, but it's not on my like laptop or something. It's the like office computer. So
Oh,
It's possible that it's some issues with like permissions or something.
Yeah,
I don't know.
he set up to not let you install a C library.
It's weird though that it says, you know, the install.packages is like, yeah, everything worked fine.
yes.
And then you try to load it and it doesn't work. Yeah, I'm stumped.
Yeah. Anyway, I mean, thanks for the workshop.
Yeah,
It
sorry we
was
can't
good.
figure out
Yeah.
the, yeah.
Yeah, it's fine. Okay, thank you.
Yeah, thank you.